Hi, this is Tim. Today we're going to go through how to program a PID instruction in RsLogix 500 for the Allen Bradley Micrologix 1100 PLCs. Please take a moment to like this video and subscribe to our channel. We put out at least one automation video a week. And put any questions that come up in the comments. Your question this week could easily be next week's automation topic. Also, if you're coming to us in the middle of this series, then look down in the description where I will have a link to all the videos of our PID series, because we've gone through why we use PIDs, why other control methods may or may not work, and we're breaking down what is the P, I, and D of PID. So while those are written in Studio 5000, after this lesson, you should be able to follow along with those in RsLogix. For this video, we are using our Micrologix 1100 trainer, and we're using Industrial Concepts PID trainer. And in the link that I have in the description, it goes through an overview of this and how we've interfaced the two together. We're going to start off exactly where we left off in the last video, where we were testing our I/O interfaces between the trainers. And we are just going to jump right into the ladder logic. The first thing we're going to need to do is we're going to need to scale this value here. So we have a sensor up here that's looking at the position of this ball as it runs up and down. And right now it is just in raw units. Actually, the full scale is 0 to 16,383. What we want to do is we want to get this into a value that we can interpret. We have our 0 value because it's sitting here right now. So let's open up our input data table. And if yours looks like a bunch of 1s and 0s where you're in a binary view, down here on Radix, just click there and you can select decimal. And yeah, we're bouncing right around 300. So our 0 is going to be 300. So now what we need to do is see where we're at this 12 mark on our scale. We're going to go to our output data table and again switch our radix to decimal, and then the control of our fan speed is O:1.0, and let's just throw 30,000 right there. Turn our trainer on, and yeah, I'll call that 12 inches. We go back to our input data table, we're at about 12,000. So our 0 point is going to be 300 units, and our 12-inch point is going to be 12,000 units. Now that's completely coincidental that it ended up at 12,000. So what we're going to do now is we're going to scale it with an SCP instruction. So we're going to bring a new rung down, and we're just going to type SCP. And our input is going to be our sensor, which is at I:1.0, and that is going to be our raw level input. And then our input minimum is those units that we were seeing. So it was about 300 for our input minimum, and our max is 12,000. And we want to put that into units so we can understand, and that's going to be inches. So our scaled minimum is 0, and our scaled maximum is going to be 12. And then we're going to put that in a floating point number. That way we can see the decimals of precision of it. So we're going to use F8:0, and we'll call that our actual level. So that gets that into some units that we can understand. But now we need to get the desired level, or our level set point, into something that our PID can understand. Now in our previous video, we configured this analog input to be scaled for a PID. So it's already ready. So to get our set point ready for that PID, all we're going to do is do the opposite with our SCP instruction. So follow along with me on this. We're going to bring another rung down, and we're going to use another SCP instruction, or scale with parameters. And this time for our input, we're going to use F8:1, which is an unused floating point number right now. And that is going to be our level set point in inches. And then our input minimum and maximum is going to be our units that we're understanding, which is 0 to 12 inches. So we'll put 0 and 12. And then our scaled minimum and scaled max are going to be what our input minimum and input max were in our previous SCP. So it's going to be 300 to 12,000. So our scaled minimum will be 300. Our scaled maximum will be 12,000. And then we're going to output that to N7:0, which is an unused integer. And we will call that level set point scaled for PID. So now let's add our PID instructions. So we'll bring another rung down and let's type PID. Now I'm typing all these in, but you can actually find all of these up here. If you go over to the, is it file miscellaneous, I believe? Yeah, there is your PID instruction. So you can find all of them up here and drag it down if you prefer. So the first thing this is asking for is a PID file. And what that is going to be is it's going to be a data type of PD. So if we go and right click our data files and click new, under type, we can go and we can find the PID data type. And we'll just click OK. And that is going to bring us with this PD9. So now we can go PD. It's going to bring up our PID 9:0. What that is that's going to be where all of our PID parameters are stored. So next we have our process variable. And that is going to be what are we trying to keep at a certain point. And that's going to be our level sensor. Now this is going to need to be that raw level data. So up here we've scaled this where we can understand what's going on now, but we need to look at I:1.0. We're just going to type I:1.0, and then it's asking us for a control variable. And this is going to be what are we trying to control to make that be what we want, which is going to be our fan speed. Now I could just type O:1.0, which is what is to our fan speed right now, but I'm actually going to put this in an integer to start with. This is an unnecessary step for this video, but in future videos we are going to need that. So I just want to build out that structure. So I'm going to put this at N7:1, and we're going to call that our PID command speed. So here is our setup screen, and for our basic PID setup, there's only a few that we really need to be concerned with. First, we have our controller gain, which is called KC. That is the P of our PID. And then we have the reset TI. That's the I of our PID. And we have the rate TD, which is going to be the D of our PID. To just get us started, we need to have something in the KC and the TI. And I'm going to arbitrarily put 1. Now watch this though. If I hit 1 and enter, it actually comes up as 0.1 because this is all in integers and it just offsets it by a factor of 10. For a KC of 1, I need to enter a value of 10. Now the reset, I'm actually going to want 0.1. So we're just going to hit 1, enter. That's going to go in. And the other one is the scaled set point, the SPS value. And that is, where do we want this to be? Now we've already scaled our set point for PID, but to get it in here, we're going to need to use a move instruction. So let's go ahead and click the OK button on this. And then let's go up here to where we scaled our set point for PID. And let's go to our user tab and hit our branch. And let's bring a branch around this SCP and add a move instruction. And we are going to move our N7:0, which is our set point scaled, to PD9:0.SPS. And that is going to be our PID set point. Okay, so that takes care of all our parameters. The one other setting that we need to concern ourselves with is what is going to be our PID update rate. So if we go back to our setup screen, I'm just going to put this at 0.1 just so it matches the rest of our video. Okay, so that takes care of our PID, but we still need to actually tie it to our fan speed output, because right now I have that PID control variable going to N7.1, and we need, at least for now, we're just going to move it to the output O:1.0. So let's bring down one more rung, and we'll use a move command. And for our source, it is going to be N7:1. And our destination is going to be O:1.0, which is our fan speed. Okay, one thing I did just catch, and really I saw it in the previous video, but it just didn't register with me, is I said we were configuring our analog for PID, and I did configure the analog input for a PID, but this analog output right here, I left it raw proportional. So it also does need scale for PID. So channel 0 of both our input and output should be scaled for PID. But now we should be ready. So let's go ahead and download this program. And if you need any help downloading your program or configuring your serial or Ethernet drivers, look down in the description. I'll have links to how to do those. And right now it looks like our command is 0 because our set point is currently 0. So let's put our set point at 6. All right, and it goes up to 6 decently. You can see it's oscillating a little bit. That's not that bad. Let's see what happens when we open our valve up. Okay, now we have some oscillation. And so that is what our future videos are going to show you, is really how we can make a PID that can compensate for this bouncing up and down, but still, if our parameters change to say that, it'll still be steady there. So you should now be ready to join us for the rest of our PID lessons with your Micrologix 1100. Again, I hope it's one of our trainers. Also, be sure to have a look at Industrial Concepts PID Trainer. The more I work with this, the more I'm really liking it. Speaking of likes, please hit that like button on this video. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!